How to access our website. Go to any browser and type search creators. Click on the first link. Now you have entered our home page where 50k plus study materials are available along with 1000 plus project ideas. We have 10 plus expert members in our team and we also support 50 plus engineering domains. In navigation bar, select University study materials. There are three streams available: computer science, information science, and artificial intelligence and data science. For now, we will click on computer science. Now we will be able to access all the study materials of different subjects of different.
Everyone, welcome back to Search Creators YouTube channel, your trusted partner for innovative tech solutions and study material. We are going to look at the next topic in Module 1, which is System Models for Distributed and Cloud Computing. In System Models for Distributed and Cloud Computing, we look at how the distributed and cloud computing systems are and what they are meant for. Built over a large number of autonomous computer nodes. They are built over a large number of autonomous computer nodes. Nodes are interconnected using SANs, LANs, WANs in a hierarchical manner. SAN in the sense satellite area network, LAN in the sense local area network, WAN in the sense wide area network. Clusters of clusters can be created using WANs for large-scale systems. What it means is clusters for clusters can be generated using wide area network for large-scale systems. Like if there are more number of systems, by using WANs, cluster of clusters can be generated. These systems are highly scalable, supporting web-scale connectivity. These systems, these systems in the sense distributed and cloud computing systems are highly scalable. Like they support more number of systems, supporting web scale connectivity. Next, look at a table which represents the classification of parallel and distributed computing systems. How many classifications are there in the parallel and distributed computing systems? They are computer clusters, peer-to-peer networks, data and computational grids, cloud platforms. Let's look at what are the features in these classifications. In computer clusters, the architecture, network connectivity and size. These components, how they differ in each classification, we'll look at it. Network of compute nodes interconnected by SAN, LAN and WAN hierarchically, which means that the network of computer nodes are interconnected by either satellite area network, local area network or wide area network hierarchically. Next is peer-to-peer networks. In peer-to-peer networks, it is a flexible network of client machines logically connected by an overlay network. Like peer-to-peer networks, they are flexible type of networks of client machines logically connected by an overlay of network. Next is data computational grids. Let's look at the architecture network connectivity of this classification. Heterogeneous clusters interconnected by high-speed network links over selected resource sites. It means that the clusters are interconnected by high-speed network links over a few selected sites only. Next is cloud computing. virtualized cluster of servers over data centers via SLA. As we know that cloud computing platform offers virtualization. What virtualization does is it gives an virtual storage or virtual working space for the users. Virtualized clusters of servers over data centers. Like we know that cloud computing provides a virtualized platform for users to work with. Now let's look at the control and resource management of each classification. The computer clusters are homogeneous nodes with distributed control running Unix and Linux. The computer clusters are homogeneous nodes with distributed control running Unix or Linux. P2P networks. These are autonomous client nodes free in and out with self-organization. Like autonomous client nodes, like they are not in a controlled manner, free in and out with self-organization. They have self-organization and they are free in and out. Next is data or computational grids. Centralized control, server oriented with authenticated security. It has a centralized control, server oriented, like it's based on the server with authenticated security. Authenticated security means only the authenticated person can use or log into the computational grids. Next is cloud platforms. Dynamic resource provisioning of servers, storage, and network. As I said that cloud computing gives virtualized working space. In that virtualized working space, storage, network, server, along with that cloud computing, like cloud platforms provide dynamic resource provisioning of servers, storage, and network. Next is applications and network centric services. Now let's look at the applications of the classifications and network centric services provided by them. Computer clusters, high performance computing, search engines, web services are provided in computer clusters. Next is peer-to-peer networks. In peer-to-peer networks, most appealing to business file sharing, content delivery, and social networking. In peer-to-peer networks, it provides sharing, content delivery, and social networking, and it is most appealing to business file sharing. Next is data or computational grids. In this distributed supercomputing, global problem solving, data center, data center services. What the data or computational grid provides is it provides distributed supercomputing, global problem solving, and data center services. Lastly, we are going to look at cloud platforms, upgraded web search, utility computing, and outsourced computing services. Like the cloud platforms provide upgraded web search, utility computing, and outsourced computing services. The cloud platform provide these services. Lastly, we are going to look at representative operational systems. In this, let's look at computer clusters. Google search engine, Sunblade, IBM Roadrunner, Cray, XT4, etc. The operational systems which are available in computer clusters are Google search engine, Sunblade, IBM Roadrunner, Cray X24, etc. Let's look at peer-to-peer networks. In peer-to-peer networks, Nutella, Emule, BitTorrent, Napster, Kazaa, Skype, JXTA. These are the operation systems provided in peer-to-peer networks. Next is data computational grids. In data computational grids, TeraGrid, Griffin, UK, UKIGI, dgrid, China grid. These are the operational systems provided in data or computational grids. Next is cloud platforms. We know that Google App Engine, IBM Blue Cloud, AWS, which is Amazon Web Services, and Microsoft Azure. These are the operational systems which are available at cloud platforms. Next, we are going to look at classification of massive systems. In classification of massive systems, majorly there are four types, which are clusters, P2P networks, computing grids, and internet clouds. They involve hundreds and thousands or even millions of participating nodes. Clusters, they are popular in supercomputing applications. P2P networks, used in business application but face copyright concerns. Like they are used in business applications, but one drawback is but they face copyright concerns. Grids. Next is grids. Underutilized due to middleware and application inefficiencies. Grids are underutilized, like they are not utilized more. Why? Because middleware and application inefficiency. The middleware and application are inefficient in grids. Next is cloud computing. In cloud computing, it is cost effective and simple for providers and users. Like we know that in classification of massive systems, in the major four types, cloud computing is the most popular, most cost effective and simple to use for the users. Next we look at clusters of cooperative computers. A computer cluster consists of interconnected computers working as a single unit. What is a cluster? What is a computer cluster? A computer cluster consists of interconnected computers working as a single unit. It means that two or more computers are working together or interconnected together to work as a single unit. Handles heavy workloads and large data sets efficiently. What they do is they handle heavy workloads and they efficiently manage large data sets also. This is the diagram for cluster architecture. This is an important diagram. In cluster architecture, look at in this figure we can look at the satellite area network, local area network, and NAS networks like Ethernet, MireNet, and InfiniBand, etc. This is an important diagram when it comes to cluster architecture. In cluster architecture, it uses low latency, high bandwidth interconnection networks. Example, satellite area network and local area network. Built using gigabit Ethernet, MireNet, or InfiniBand switches. They are built using the Ethernet, MireNet, or InfiniBand switches. They are connected to internet via VPN gateways. VPN means virtual private network gateways. Cluster nodes often run under different OS leading to multiple system images. The cluster nodes present in this architecture run under different operating system leading to multiple system images. Next we look at single system image, which is SSI. Single system image. It is an ideal cluster design merges multiple system images into a single system image. What the SSI does is it merges multiple system images into a single system image. SSI makes a cluster appear as a single machine to the users. For the users, it makes them to feel like only a single system is working, not multiple systems are connected together. It doesn't make them feel like that. It makes the users feel like they are working with a single machine only. It is achieved using middleware or OS extension. How it achieves this is by middleware or operating system extensions. Next is hardware, software and middleware support. Cluster nodes include personal computers, workstations, servers or SMP. Cluster node include PCs, workstations, servers or SMP. PCs, workstations, servers or SMPs. SMPs means symmetric multiprocessing. Next is MPI and PVM used for message passing. What we mean by MPI and PVM is MPI is message passing interface. PVM is parallel virtual machine. They are used for message passing. Most clusters run on Linux OS. Most of the clusters run on the Linux operating system. Middleware is essential for SSI, high availability and distributed shared memory. The middleware is essential for the SSI. SSI means single system image, high availability and distributed shared memory, which is DSM. Next is virtualization allows dynamic creation of virtual clusters. In the virtualization allows the dynamic creation, like we can change the creation of like ever changing creation of virtual clusters, like it is not static. Next, major cluster design issues. What are the design issues in cluster designs? No unified cluster wide OS for resource sharing. Like there is no unified cluster wide operating system for the resource sharing. This is one of the design issues. Next is middleware is required for cooperative computing and high performance. Like middleware is required, like it is essential for cooperative computing and high performance. Without middleware, it cannot perform these operations. Benefits of clusters. Now let's look at what are the benefits of the clusters. Scalability, efficient message passing, fault tolerance and job management. These are the benefits of clusters. Now, grid computing infrastructures. In this table, we can look at the critical cluster design issues and feasible implementation. If you have downloaded the notes, you can go through this. It's also important. Now let's look at how the evolution took place to the grid computing. Internet, web and grid computing. What grid computing does? It enables interaction among applications running on a distant computers. What it does? What does the grid computing do? It enables the interaction among the applications running on a distant computers. Grid computing supports a rapid growing IT based economy. The grid computing supports rapidly growing IT based economy, like it's very supporting to the IT economy. Why? Because interaction among applications running on distant computers can be achieved through grid computing. Next is computational grids. In computational grids, it is similar to an electric power grid integrated computers software. It integrates computer software, middleware, and users. It is similar to an electric power grid. What it does, it integrates computers, software, middleware, and users. It is constructed across LANs, WANs, or the internet at various scales. Virtual platforms for it it supports the virtual platforms for virtual organizations. Next is computer used. Workstations, servers, clusters, supercomputers. What are the computers used in computational grids? They are workstations, servers, clusters, and supercomputers. Personal devices, which are PCs, laptops, and PDAs, can also access grid systems. This is an example for computational grid. Built over multiple resource sites owned by different organizations. Offers diverse computing sources, like for example, workstations, large servers, Linux clusters. It uses broadband IP networks, LANs, WANs to interact computing, communication, and content. Special applications. Search for extraterrestrial life. These are the special applications. Astrophysics research, pulsar. Search for extraterrestrial life, in the sense we believe that life is only on Earth. Search for extraterrestrial life means the life beyond the Earth, the life which exists beyond our planet. To search if there is a life existing, like on Earth, we are the living organisms. Like us, if there are any living organisms present in another planet, it is used to search for them. Example for large grids. NSF TerraGrid USA, EG Europe, China Grid China. Next we are going to look at grid families. Let's look at the definition. Grid computing integrates distributed resources to solve large-scale computing problems. This is the definition of grid families. What are the types? Computational or data grids, P2P grids. These are the types. This is the diagram representation. Now let's look at the types. Computational or data grids, built at a national level for large-scale computing and data sharing. P2P grids, decentralized and self-organizing without a central control. This is the diagram. One table is also present, like this table represents two grid computing infrastructures and representative systems. You can go through this. Next is peer-to-peer network families. Client-server model. Traditional architecture where client connect to a central server for computing resources. What is client-server model? It is a traditional architecture where client connect to a central server for computing resources. P2P architecture. Decentralized, they are decentralized with each node acting as both a client and a server. Next we look at P2P systems. Decentralized control. No master slave relationship, no global view of systems. In decentralized control, there will be no master slave relationship or there will be no global view of system. Self organizing. What is self organizing? Organizing. Peers join and leave voluntarily. Whenever they want, they will join and leave. It is a voluntary response. ADHOC network uses the internet like TCP, IP, NAI protocols. What is ADHOC network? It is a temporary wireless network that allows devices to connect directly without a central router or server. Like the ADHOC network is a wireless network. It doesn't need any central router or server to connect with the devices. Next is overlay networks. This is the diagram representation of the overlay networks. Virtual network over physical P2P networks. What are the types in that? Unstructured overlay, structured overlay. In unstructured overlay, random connections, flooding based search. What are the types in virtual network over physical P2P networks? Unstructured overlay. They are random connections or flood based search. Structured overlay, organized topology, efficient routing. What are these are the features of unstructured overlay and structured overlay. P2P application families. What are the application families in P2P, peer-to-peer? File sharing, collaborations, distributed computing, P2P platforms. In file sharing, for example, BitTorrent and Napster. In collaboration, Skype and MSN. In distributed computing, ACTI at home, like we earlier saw for extraterrestrial life searching. P2P platforms, example JXTA or NET. Next is challenges faced in P2P computing. These are the challenges. Major categories. P2P computing challenges. Heterogeneity, hardware, software, and network incompatibilities, scalability, handling increased workloads, security and privacy, lack of trust, copyright concerns, performance issues, data location, routing efficiency, or load balancing, fault tolerance, replication prevents single point of failure. These are all the computing challenges in P2P. Next is cloud computing over the internet. Cloud computing is a revolutionizing computational science by enabling large-scale data processing with efficient resource allocation. It shifts computing and data storage from desktops to centralized data centers offering on-demand services. Cloud computing, what it does, it moves computing from desktops to large data centers, enables on-demand software, hardware, and data as a service. It supports scalability, redundancy, and self-recovering systems. Next is internet clouds. This is a diagram representation. It uses virtualized platforms for dynamic resource provisioning, provides cost-effective solutions for both users and providers, ensures security, trust, and dependability in cloud operations. These are some information about internet clouds. Next is the cloud landscape. Cloud computing addresses challenges in traditional distributed computing systems such as maintenance, poor utilization, and high costs. It provides scalable on-demand computing resources through various service models. Challenges in traditional systems. It requires constant maintenance, suffers from poor resource utilization, have high costs for hardware and software upgrades. What is the cloud computing as a solution? What it does for us to find a solution? It provides an on-demand computing paradigm, offers scalable and cost-efficient alternative to traditional systems. Next, look at the cloud service models. The service models in clouds are infrastructure as a service, platform as a service, software as a service, infrastructure as a service. Provides virtualized computing resources like servers, storage, networking. Users manage applications but not infrastructure. Let's look at platform as a service. Offers a virtualized development platform with middleware, databases, and APIs. Example Java, Python, Web 2.0. Lastly, software as a service. It delivers software applications via browsers. For example, CRM, ERP, HR systems without upfront infrastructure investment. This is the diagram representation of the different models. Now let's look at the cloud deployment models. Mainly there are four: private cloud, public cloud, hybrid cloud, managed cloud. In private cloud, it is exclusively used for a single organization or a single user. By this, it provides high security. Public cloud service available to multiple users with low cost. Even the security is low in public cloud. Hybrid cloud combines private and public cloud benefits, like some information must be shared in public and some information must be private. For this purpose, hybrid cloud can be used. Managed cloud maintained by third party providers for efficient management. These are the different cloud deployment models. Next is security considerations. Different service level agreements define security responsibility. Security is shared among cloud providers, users, and third party software providers. What are the benefits of cloud computing? It provides efficient location based data centers with better energy management. It provides a location based, like whatever the location, it is based on that data centers with better energy management, better resource utilization through peak load sharing, like it provides better utilization, reduces infrastructure maintenance efforts, significantly lowers computing costs, facilitates cloud based programming and development, enhances service and data discovery along with constant distribution. Like along with doing the constant distribution, it provides enhanced service and data discovery, addresses privacy, security, and reliability challenges, supports flexible service agreements, business models, and pricing policies. This is all about the further topic in the first module, which was the system models for distributed and cloud computing. Hope you understand the video. Like I have explained in some places, like I have not went in depth because of we need like more time to finish only one topic of the module 1. For that, I have explained some topics not in depth. Like it is understandable like it's in the understandable form only. So this is all about today's video. Stay tuned for the further videos on the cloud computing module 1. Thanks for watching the video. Like, share and subscribe to our channel.